Most moons in our solar system look kinda similar, cold, gray, and covered in craters. But then there's Jupiter's natural satellite, Io, the angriest, most volcanically active moon in the entire solar system. It looks like a moldy pizza, smells like rotten eggs, and is currently exploding. While its neighbors are frozen and maybe hiding life, Io is blasting volcanic plumes 200 miles into space. Jupiter is truly giant. You could fit about 1,300 Earths inside it, so it sort of makes sense that it has more mass. More mass means more gravity, so much so that it basically makes Jupiter a moon magnet. It has 95 officially recognized moons, and most are tiny captured rocks, basically space rubble that got trapped. However, only 4 of them stand out as Jupiter's VIPs, with Io being the one that orbits closest. It's a bit larger than our moon, but the vibe is the opposite. Our moon is dusty and quiet. Io looks like a toxic chemical spill, and here's why. Io is caught in a gravity trap. Jupiter yanks on it from one side, and its neighbor moons impact it too. For every 4 orbits Io makes, Europa makes 2, and Ganymede makes 1. That timing keeps Io's orbit slightly off, so the squeezing never stops. This creates tides, but not ocean tides, rock tides. On Io, the solid ground bulges up and down by as much as 330 feet every single orbit. And since Io flies around Jupiter every 42 hours, it's a never-ending cycle. All that bending creates friction deep inside. It's like bending a paperclip back and forth. Do it fast enough and the metal gets warm. Except here, it gets hot enough to melt rock into magma. And that heat has to escape, so the pressure punches through the crust in hundreds of places. Some estimates put Io at around 400 volcanoes, and they don't all behave the same. Sometimes lava crawls across the ground. Other times, Io goes full cannon and blasts an eruption cloud of gas and dust hundreds of miles in the air. Imagine if an erupting volcano on Earth could reach all the way up to the International Space Station. This can happen because Io has lower gravity and a super thin atmosphere, so there's not much to slow the blast down. Plus, in near vacuum, hot gases expand fast and shove dust and volcanic material outward in huge arcs you could spot from far away. Non-stop eruptions are also why the moon looks like a giant marble dipped in mixed paint. Sulfur frost falls like dirty snow and stains the surface yellow, red, and black. Io is also famous for its lava lakes, and the biggest celebrity is Loki Patera, a volcanic bowl of about 126 miles across. What makes it cool is how it keeps refreshing its surface. A dark crust forms, then cracks and sinks. That can trigger a wave of fresh lava that rolls across the lake like a reset button. That's why Io has no craters from previous impacts like our moon or Mars. You'd expect the volcanoes to be mountains like Fuji or Etna. On Io, a lot of them are more like giant flat pits. The real mountains look like jagged slabs, like broken glass sticking out of the ground. The biggest one, South Bosal Mons, rises about 11 miles. That's like 2 Mount Everests on top of each other. These mountains don't grow like they do on Earth. Here, mountains don't usually build slowly because tectonic plates shove together, and the crust wrinkles up like a rug. On Io, it's like repaving the same street again and again. Eventually, the buried layers crack and huge slabs pop up sideways into jagged mountains, kind of like floor tiles snapping and popping upright. So where is all this lava coming from? For a long time, people thought Io had a global magma ocean right under the crust, basically a planet-sized water balloon, but filled with lava. Jupiter and other moons squeeze that balloon a bit and lava comes out. But according to the latest findings from NASA's Juno spacecraft that orbits Jupiter, that's not what's happening. On close flybys, Juno feels Io's gravity tug and uses that to measure how much the moon squishes. And Io doesn't squish like it has a shallow global lava ocean. The latest gravity measurements suggest the inside is mostly solid rock, but with lots of separate pockets of melted rock. It's not a balloon, it's more like a kitchen sponge, but instead of water, it has magma in different spots. That explains why the volcanoes are so chaotic. They're not all pulling from one global lava ocean. Many are likely fed by their own local magma chambers, so eruptions can pop off in different places, in different ways. All that chaos doesn't stay on Io. The colorful moon constantly leaks sulfur gases into space, and Jupiter's magnetic field scoops a lot of it up and spreads it into a glowing donut around the planet, right along Io's orbit. Scientists call it the Io plasma torus, and Io keeps refilling it at a rate of around 1 ton of material every second, like a moon-sized smoke machine that never turns off. But there's more. Io isn't just a volcano moon, it's like a giant space battery. As it races through Jupiter's enormous magnetic field, electricity builds up across it, the same way static builds up before a shock. That charge reaches around 400,000 volts, the kind of power used to move electricity across entire countries. And it drives an electric current of about 3 million amps. For scale, that current is like hundreds of thousands of home circuits running at once. That electricity doesn't stay on Io. It shoots along Jupiter's magnetic field lines in an invisible tube straight down into Jupiter's atmosphere. And where it hits, Jupiter lights up with a bright aurora spot called Io's footprint, like Io is dragging a glowing cursor across the planet. And as if the volcanoes and the lightning leash weren't enough, Io has one more trick. It loses its atmosphere once a day. Every time Io slips into Jupiter's shadow, the sunlight cuts off and the surface temperature drops. It gets so cold that the atmosphere literally freezes solid and falls to the ground as sulfur snow. For a couple of hours, the atmosphere deflates like a popped balloon. Then, Io comes back into sunlight, the frost warms up, turns back into gas, and the atmosphere refills again. It's like the moon is holding its breath behind Jupiter, then gasping back to life when the lights come on. And it's the same sulfur chemistry that paints the surface, so the moon is literally frosting and repainting itself as it goes. Studying Io is like watching a cosmic physics experiment run in real time. Juno taught us that tidal heating is messy. We used to think gravity melted a moon evenly to create a smooth layer of liquid inside. Io proves that wrong. The new data shows the interior is a sponge. Gravity melts specific pockets of rock, leaving the rest solid. This changes how we think about life on Europa and Enceladus, the icy moons that likely hide oceans under their ice. People get excited because heat from the rocky interior could power hydrothermal vents, and vents are like underwater chargers for life. But Io suggests that tidal heating might not warm the inside evenly. It might create scattered hot pockets, like a sponge with random warm spots instead of one steady heater. If that's true, vents on the seafloor might be rare and clustered. Life would not be spread across the whole ocean. It would gather around a few hot oases in a huge, dark, freezing sea. Io could also be like a mirror of Earth's past. Its lava temperature is closer to the super-hot lavas our planet likely had billions of years ago. On Earth, the surface gets recycled and overwritten, especially on the ocean floor, so the oldest footage is missing or scrambled. But by watching Io, we can get a rare real-time glimpse of the kind of super-hot volcanism Earth may have gone through early on, before the planet cooled down and long before life began. Io is incredibly fascinating. It's a world where the ground breathes fire, mountains snap up like broken tiles, and Jupiter literally plugs into an aurora. If this is what one little moon can do, just imagine what else is out there in the deep, dark space.
Imagine a still, frozen world. It's ancient, about 4.5 billion years old. It's barely heated by the rays of the sun and covered with a thick layer of ice. This world is smaller than our moon, but a bit larger than Pluto. Its name is Europa, the sixth satellite of Jupiter and one of the biggest moons in the solar system. But the coolest thing about this faraway place it might host life. Astronomers consider Europa one of the most promising places in the solar system to search for new life forms. All because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick. But it is still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space. Of course, it's going to be challenging for any life-seeking missions to access such a deep environment. On the bright side, scientists already have some evidence that there are way shallower pools that probably lie much closer to the surface of the moon. They might be located even less than 1 mile under the ice. And there are two great things about this news. First of all, it boosts the odds of life existing on Europa. And secondly, if it's true, it can make it easier for future missions to find these life forms, if there are any. Interestingly, the new discovery about these shallow pools came about by sheer luck. The scientist leading the research, Riley Kohlberg, accidentally saw a presentation of his colleague, a planetary scientist. That scientist showed a picture of double ridges on the surface of Europa, and Kohlberg remembered that he had seen similar ridges on Earth. But while such formations are rare on our planet, they are way more numerous on Europa. The following studies suggested that the ridges on Jupiter's moon might be the result of a specific cycle, similar to that on Earth. In this cycle, liquid water freezes and then thaws inside an ice sheet, which is a rather high-pressure environment. This causes the sheet to move upward over and over again, creating a two-peaked structure. Or at least that's what happens on Earth. If the processes on Europa are similar, it can prove the presence of shallow waters on the satellite. Of course, the temperature, pressure, and chemistry are very different on Europa. And scientists don't know yet how the ice behaves there. That's why they can't understand how deep or large the water pockets are, or how long they need to refreeze. But what is more or less clear is that such under-ice environments on Europa are very likely to be protected from Jupiter's harsh radiation battering the satellite's surface, which in turn increases the chances of life existing on Europa. Now, can we get back to the fact that the ocean on Europa seems to be salty? Red streaks on the satellite's surface might have this color due to their chemical content. They're likely a frozen mixture of water and salts. This is quite unusual because such a composition doesn't match any known substance here on Earth. As for yellow spots on Europa's surface, those might be caused by the presence of sodium chloride. You know this substance as good old table salt. Scientists tried to recreate the conditions on Europa in a lab. They discovered that by combining water, table salt, freezing temperatures, and high pressure, they could get a new kind of solid crystal. This substance might exist both at the bottom of Europa's ocean and on the moon's surface. But besides this information, researchers are in the dark. Hopefully, we'll find the answers to some of these questions around 2030. That's when a mission called Europa Clipper, which is going to be launched by NASA, will probably reach Europa. The mission is going to have several close flybys and figure out if any form of life can exist on the moon. The European Space Agency's JUICE, which stands for the Jupiter Icy Moons Explorer, is going to visit Europa in the next couple of years too. But Europa isn't the only place in the solar system that might host or once hosted life. In 2003, Mars Express, a spacecraft launched by the European Space Agency, discovered methane in the atmosphere of Mars. On our planet, the biggest part of this gas in the atmosphere is produced by living creatures, for example by cattle digesting food. However, scientists think that methane was stable in the Martian atmosphere for about 300 years. And then, in 2006, the methane almost entirely vanished from the red planet. And it happened 600 times faster than researchers' models accounted for. The question, what or who generated the gas? And where did it go? Another Martian mystery is microbes that may be sleeping beneath the surface of Mars. There, they might have been protected from the harsh radiation coming from space for millions of years. Scientists simulated the conditions on Mars in a lab to check if it could possibly be true. And they were amazed to find out that bacteria could easily survive in such conditions for 280 million years. which means that if life existed on Mars, we could find the evidence in the planet's subsurface by drilling into the Martian soil. Right now, there is no flowing water on Mars, and cells or spores would simply dry out. Plus, the surface temperature is similar to that of dry ice. In other words, the surface of the planet is deeply frozen, and still, there could be 6 types of bacteria and fungi living underground on the red planet. The most likely of them is nicknamed Conan the Bacterium due to its tough nature. Well, I guess time will show. Now let's move to Venus. In 2020, scientists announced that in the toxic Venusian atmosphere, there was something that might mean the existence of life. Unfortunately, scientists didn't have any evidence, since there was no chance to collect any microbe specimens or snap any pictures of extraterrestrial life. But they claimed that they had discovered a chemical called phosphine there, and it was a big deal. If it wasn't some previously unknown chemistry that was producing this gas, then there could be some kind of microbial life involved in the process. Phosphine is made up of 3 atoms of hydrogen and 1 atom of phosphorus. This gas is toxic to any terrestrial life form that needs oxygen, including us humans. On our planet, phosphine can be found in places with no or little oxygen, for example, marshes and swamps. The gas is created by complex mixtures of bacteria living there. It can also be produced industrially. Come to think of it, phosphine isn't supposed to be in Venus's atmosphere altogether. This gas needs precise pressure and temperature and tons of hydrogen to form. It wouldn't be all that surprising to find it on Saturn or Jupiter, famous gas giants. But on Venus, totally unexpected. There's no way phosphine can be naturally produced on this planet. Tiny amounts of it can be created during volcanic eruptions, lightning storms, minerals blown up to the surface, or meteorites entering Venus's atmosphere, but not as much as astronomers thought they had observed. And it had to make scientists suspicious, but they were too happy about their discovery. They probably thought it meant there could be life on Venus. But even if this gas was created by some mysterious organisms, it would be a big question how they survived on Venus. On our planet, some microbes can thrive in environments with an acidity of 5%, but no more. On Venus, though, clouds are almost entirely made of acid, containing more than 90% of sulfuric acid. The Venusian atmosphere is also 50 times as dry as the driest place on our home planet. And indeed, in 2022, thanks to better and more high-resolution telescopes, it was concluded that there was no phosphine in Venus's atmosphere. Or even if there was, it was a very small amount. So far, we need to look for signs of life further away from Earth.
Jupiter has 79 known moons, and the 4 biggest of them that are particularly interesting are Galilean moons. They were named after Galileo Galilei. He discovered them in the 17th century. They have something in common, but at the same time are all very different. Europa is the smallest of the Galilean moons with a diameter of 1,860 miles. It orbits Jupiter every 3.5 days. The first images we got from there were taken in the 1970s. Its surface mostly consists of water ice. Europa has long fractures, often around a mile wide, that can extend for thousands of miles across its surface. They were probably formed as the crust pulled apart from tidal forces on the mysterious ocean beneath the surface. In 2012, scientists discovered water vapor plumes erupting close to its south pole, rising up to 125 miles. These plumes can help us find what's inside Europa without having to land there. Scientists think there could be a magnificent ocean hidden 10 to 15 miles beneath the solid surface. That ocean could be 40 to 100 miles deep. Even though it's just 1/4 of Earth's diameter, it contains twice as much water as all of our oceans together. This ocean is a potential environment for some forms of life. Scientists believe the entire ice crust is floating on that ocean. It probably makes a full rotation around Europa once every 12,000 years. In the image the Galileo spacecraft took, you can see small dark brown spots. They're 6 miles across and formed as the hot, less dense material was getting to the surface. It either pushed the crust or broke through it altogether. The surface of Europa consists of so-called chaos terrains. They're rough areas surrounded by a smoother surface. Its equator could be covered in ice spikes called penitentes that can go up to 50 feet high. We have them on Earth too, especially in dry areas at high altitudes. But none of them are as big as those on Europa. Our moon has over 5,000 big craters with a diameter of more than 15 miles. Europa's surface lacks impact craters and doesn't look like it's more than 50 million years old. This means the surface of Europa is changing and reforming all the time. This moon is icy and is one of the smoothest of any solid space objects in our solar system. Because of it, it's 5 times brighter than our moon. Europa is under a constant blast of radiation coming from Jupiter. It's so strong, we wouldn't last even a day there. Europa is 5 times further away from the center of our solar system than Earth. That means it barely gets any heat coming from the sun, so it can remain frozen since the average temperature is negative 250 degrees Fahrenheit at the equator and around negative 360 degrees Fahrenheit at the poles. About 40 years ago, the Voyager 1 spacecraft came close to the rocky moon Io and discovered that it's a volcanic champion of our solar system. Io is Jupiter's 5th innermost moon, 4.5 billion years old, nearly the same age as Jupiter itself. It's similar in size to our moon, and even has a similar density and amount of gravity. Many moons in our solar system consist of silicates and water ice, but Io is made of iron and silicate rock. You'd be able to see some beautiful auroras on Io. As this moon rotates around Jupiter, auroras change brightness all the time, but they're always there. Io is relatively close to Jupiter, almost 260,000 miles above its cloud tops. If you could come to Io and take a look at Jupiter from there, it would appear almost 40 times bigger in the sky than our moon. Stargazing there would be amazing. Io needs 42.5 hours to orbit Jupiter. Our moon needs almost a month. At some points, Io's tidal bulge can go up to 330 feet. It's similar to what we have on Earth. The gravity of our moon causes ocean tides. Io doesn't have an ocean, but the ground itself moves and goes up and down. It's like an elevator taking you to the bottom and then the top of a building with 30 stories. The gravity of Jupiter and its other big moons affect Io, so the solid ground tides on its surface are over 5 times as high as the highest ocean tides on our planet. All this makes Io so hot on the inside that some of the inner materials melt, boil, and try to escape in any way possible. Eventually, it creates a hole in the ground, which then turns into a volcano. Io is the most active body in our solar system when it comes to volcanoes. Io has more than 400 of those, with 150 of them erupting all the time. Some of them shoot their hot gas plumes 200 miles into space. It would be difficult to walk there because we're talking about a pretty intense world of floodplains of liquid rock, huge lava flows, multiple lava lakes, and giant collapsing mountains. Ganymede, the largest moon in the solar system we know of, also has the biggest water ocean. It's 26% greater than Mercury when it comes to volume, but it's less dense. This giant moon has a thick crust of water ice 90 miles deep. There might be a huge ocean of liquid water underneath. It extends 60 miles deep, which is about 10 times deeper than the deepest point in the Earth's ocean. The Voyager spacecraft also detected polar caps made of water frost there. Ganymede is half rock, half water, including tiny amounts of metals and ice. Its atmosphere is very thin and doesn't contain oxygen. This ocean most likely doesn't contain life. The Earth is a great example of how certain microbes and creatures can survive deep down without sunlight. But the ocean of Ganymede is so deep and the pressure is so strong that the water at the bottom is probably compressed back into ice. Certain forms of life in the deepest areas of our ocean survive thanks to geothermal vents that eject minerals. Since there's likely thick ice between the ocean and the core, this isn't the case with Ganymede. But the ocean there is salty, with multiple layers divided by icy sheets. If there's any chance of life, it could be in the part where the rocky core is in contact with the most internal icy layer. Beneath all that water and ice, Ganymede is the only moon in the entire solar system with a magnetic field. It's possible because this moon has a liquid core. Ganymede circles Jupiter approximately once every 7 days. Its orbit is so eccentric that at some points, it's pretty close to Jupiter. Ganymede, Io, and Europa have gravitational forces that affect each other. In the time Ganymede orbits Jupiter once, Europa makes 2 orbits, and Io makes a full circle 4 times. 1/3 of Ganymede's surface contains big dark regions, while the other 2/3 are lighter. Dark areas are older and contain more craters. Lighter areas have long ridges and grooves, about 2,300 feet high and thousands of miles long. Callisto, the 3rd biggest moon in the solar system, 3,000 miles in diameter, needs 17 Earth days to orbit Jupiter. Its atmosphere is very thin. There are many impact craters, but its ancient crust has basically been the same for more than 4 billion years. When a planet is geologically active, like the Earth, some things can erase most of the evidence from past impacts: water, volcanoes, tectonic plate movements, human activity, and weather. All this changes the surface. Callisto has experienced none of those. Scientists think this moon used to be an ocean world that eventually froze over. It was hit by meteors from time to time, but mainly remained untouched. And yet, it still has some pretty impressive craters, like Valhalla, the biggest multi-ring crater in our solar system. That's 2,500 miles in diameter. Major craters on Callisto contain more rings than those on other celestial bodies. Whatever hit the moon was big enough to have punctured the thin crust, causing water to spread on the surface. And under this thin crust, there could be either salty ocean or soft ice. The Galileo space probe detected that Jupiter's magnetic field couldn't penetrate through this moon, likely because of a layer at least 6 miles thick. That's why it's hard to explore Callisto. Moons like Europa have vents that eject water from the subsurface oceans. But to explore Callisto and discover more about its past, we'd have to use the old-school way, digging through the crust. If we wanted to explore the outer parts of our solar system, Callisto would be a great spot because Jupiter's radiation doesn't reach it. So we'd be safer there than on some other inner moons.
Hey, wake up! Quick, listen to that. It's a 5-second FM signal coming from one of Jupiter's moons. You fumble for your phone and inform your colleagues. They freak out over the news and rush to the lab. You've been a scientist working with the Juno probe, exploring Jupiter for years. But this is the first time you've witnessed something so unusual. Ganymede is Jupiter's largest moon and the biggest moon in our solar system. If this space body didn't orbit around Jupiter, it would be classified as a planet. It's even bigger than Mercury and Pluto. What makes this moon stand out among others is the fact that it has its own magnetic field. The moon was born around 4.5 billion years ago. It means it's as old as Jupiter itself. This planet-sized space body takes 7 Earth days to orbit its planet. Everyone gathers at the laboratory, impatiently waiting for you to play the recording of the signal coming from space. Your colleagues get their game on, trying to figure out what the source of this mysterious sound is. Around 40% of Ganymede's surface is dark, with craters scattered around, and 60% is light-colored. There are formations that were probably caused by tectonic activity or the release of water from under the surface. Scientists managed to discover a thin layer of oxygen trapped in the moon's atmosphere. The temperatures there are super low, between -170 to -200 degrees Fahrenheit. There isn't much information about how the moon behaves or what chemical elements it hides inside. Some of your colleagues try to create the same conditions that existed when the sound was transmitted. For hours, they sit there waiting, but nothing. Maybe it was a fluke. You get to the control system and activate the Juno spacecraft. The main point of this mission is to observe Jupiter's gravity, magnetic fields, the atmosphere, and the planet's evolution. By the way, there's also some evidence that Jupiter's largest moon is evolving too. Since it has a magnetic field surrounding it, auroras pop up all the time. Those are glowing gas circling the moon's north and south poles. If life existed in such a place, it would probably be at the bottom of Ganymede's extremely salty ocean. For a long time, scientists thought that the sun was a crucial component to kickstart life. But now we know that there are organisms dwelling deep at the bottom of the oceans. Those are doing just fine without sunlight. The oceans of our planet are teeming with some of the most bizarre creatures of all shapes and sizes. Sea lilies live some 10,000 feet underwater. They got their name because they look like flowers, except they're not plants but animals. Don't be fooled by their stems and leaves. Those are body parts equipped with nerve endings to detect food around them. Goblin sharks are probably some of the most weird-looking sharks that live at the bottom of the ocean. They can grow up to 12 feet long and have a very unusual snout. Now, take a look at the anglerfish. It has a bioluminescent blob on its head to attract prey and navigate its way around the dark ocean floor. It's a natural flashlight that never needs new batteries. It's only the females that have these flashlights, though. The blobfish is another bizarre animal living down there. It lives in the Atlantic, Pacific, and Indian Oceans, 9,000 feet under the surface. Anyway, even though you asked everyone to keep the news confidential, it somehow leaks to the media and becomes a new trending topic. You get a call from a news agency. They say they want to interview you about this breakthrough that may prove life exists in outer space. The next day, you head down to the news station to talk about your discovery. You have a whole live studio audience watching your every move as you reach out to grab your glass of water. The crew scurries around doing some last-minute checkups before you're live on air. The makeup artist does some final brush-ups. The sound engineer asks you to test your mic once more. Several of the producers are sitting in the front seats. Bright lights are flooding the studio. The countdown begins. 3, 2, 1, and you're introduced, and the host asks you to explain what it was that you heard. You tell them about the Juno space probe orbiting Jupiter. After a couple of questions, the host finally brings up the most dreaded one. Might the mysterious sound be coming from another civilization? Everyone leans in, waiting for you to answer. You freeze, not knowing what to say. Even though the crushing pressure at the bottom of the ocean is 1,000 times stronger than at sea level, life still exists there. Algae, which is considered a delicacy in the ocean world, is off-menu for deep-sea creatures due to a lack of sunlight. Many of these bottom dwellers have to munch on leftovers instead. Those sink down there from the upper layers of the ocean. The freezing temperatures and the intense pressure have altered the cells of these creatures. This has made them more resilient than the average fish. Bacteria were developing their own ways of surviving. Studies show that they feed on certain gases and chemicals, like sulfur and carbon dioxide. Methane and hydrogen are released when tectonic plates move against each other, and some of these bacteria feast upon those gases too. Tardigrades, also known as water bears, are microscopic critters that can live and thrive in extreme conditions. You can find them in volcanoes, frozen glaciers, and even in the empty void of space, which means that some life forms might actually exist on Ganymede. You explain this to your audience. Then you mention that you don't have enough information to determine if it was another civilization or a natural phenomenon that produced the sound. This doesn't mean that the bottom of Ganymede's freezing oceans isn't teeming with its own bizarre and weird creatures. There might be some legendary beasts like the kraken or leviathan there, or weird glowing fish with 2 heads, a fish with tentacles and a large fin, giant crabs. The bacteria there might be as varied as our own. The plants, if they exist there, have to be strong enough to survive the sub-zero temperatures. The animals on Jupiter's largest moon could be as big as our blue whales or as tiny as plankton. After the interview, you head back to the lab to examine the records once more. On your way home, you see posters of yourself with captions like, Are we not alone? Hey, you've become a celebrity. Many people take pictures of you. You've been booked by other agencies for more interviews. Some science magazines even want to put you on the front cover as the Person of the Year. Every time you come to work, you wait for the sound to appear again. But nothing. You send a signal from the Juno probe, trying to make some sort of contact with whatever produced the sound. Nothing. That night, you pass out on your desk once more. Eureka moment wakes you up in the middle of the night. There might be something you've missed. You run the numbers again and realize that the answer was in front of you this whole time. It wasn't another civilization that produced this sound. The source was electrons. Every planet produces its own sound. It's created when charged particles from the solar wind and the planet's magnetosphere interact with one another. That's what happened on Ganymede. The electrons in its magnetic field, where the probe picked up the signal, were acting stranger than usual, and this amplified some irregular frequencies. You're embarrassed and spend the rest of your night making phone calls, telling your team the news. The agency that interviewed you releases a statement. They explain that other civilizations aren't trying to contact us. You sit back at your desk, waiting for the next big thing to happen. Europa is another of Jupiter's moons that may host life. It's made up of an iron core, a mantle, and a salty ocean, twice the volume of all the oceans on Earth. And just like Ganymede, the ocean lies under a water ice crust. Scientists claim that there might even be active volcanoes there, and some resilient bacteria may live there. With enough water, certain chemicals, and a source of energy, Europa could produce life. But it's unlikely that we'll find anything but tiny microbes. A few years ago, NASA caught a mysterious green glow on Jupiter. It was moving at breakneck speed and almost escaped detection. Could it be proof that Jupiter has secrets we've been missing for decades? And if so, how will it affect us humans on Earth? Well, the truth is, astronomers didn't just stumble across this phenomenon. They've been studying Jupiter very carefully for a long time. The reason is the Juno mission. The Juno spacecraft was launched in 2011, and it reached Jupiter in 2016. Since then, it's been orbiting the planet and collecting tons of data. Juno's job is to help us understand what Jupiter is made of, how its atmosphere works, and what's happening deep inside the planet. In 2020, one of Juno's cameras, called JunoCam, clever, captured something strange. Near Jupiter's North Pole, a bright green flash of light occurred. This light appeared to be moving very fast. Capturing fast-moving objects in space is extremely difficult. That's why this image surprised many scientists. So, what could this green glow be? The most plausible and widely accepted explanation is lightning. But lightning on Jupiter is very different from lightning on Earth. On Jupiter, lightning forms inside massive clouds made of ammonia and water. These storms are far stronger than anything we experience here, and they can produce unusual colors, including green. But what if the green glow isn't lightning at all? Why didn't we see it before? This glow could always exist, but it probably moved too fast for our cameras to catch until now. Anyway, if we spot it again, we would be able to study it more closely and figure out what's really going on. Until then, a lot of the explanations are still educated guesses. Another question is what this might mean for Earth. Scientists are sure it won't have any direct impact on our planet. But the discovery is still important. It shows that weather-like phenomena such as lightning exists on other planets, and sometimes in much more extreme forms. Like on Mars, for example. Scientists have just discovered that the planet's atmosphere crackles with static electricity. In other words, Mars has tiny lightning. Back in 2021, when a dust devil rolled over NASA's Perseverance rover, scientists expected to hear the usual stuff: sand scraping, wind rushing past. Instead, the rover picked up a faint pop. At first, it didn't make much sense, and now, researchers finally think they know what it was. That sound likely came from electricity discharging in Mars's thin air. Basically, mini lightning on Mars. It doesn't look like lightning on Earth. There are no bright flashes streaking across the sky. Mars's atmosphere is too thin for that. Instead, these are tiny sparks. Still, they count as lightning, which officially makes Mars the third planet beyond Earth known to have lightning, after Jupiter and Saturn. How did scientists find this? Well, Perseverance has a microphone called SuperCam mounted on its mast. Over 2 years, it recorded about 28 hours of Martian sound, and hidden in all that audio were 55 short bursts that matched what you would expect from small electrical discharges. The sparks were super tiny, like those little shocks you get when you touch a doorknob after walking across a carpet. Yeah. Each spark lasted only milliseconds, but 7 of them also lined up with electromagnetic interference. This is a big clue that electricity had jumped through the air near the rover. But where does this Martian lightning come from? On Earth, lightning forms inside storm clouds when ice particles collide. Now Mars doesn't have rainstorms like that. It's too cold and dry, but it does have a lot of dust. When strong winds whip dust grains around, they rub into each other and trade electric charges. Scientists use a long and complicated word to describe this phenomenon, triboelectrification. But the idea is simple. Friction builds up electricity. Once that charge grows strong enough, it releases. That release creates both sound and electromagnetic waves, the very signals Perseverance detected. These tiny sparks might sound harmless, but they matter a lot. Electrical activity can change Mars's chemistry. It may help create reactive chemicals like hydrogen peroxide and percolates, which break down organic matter. That could help explain why Mars struggles to preserve signs of ancient life. Electricity might also affect how dust moves. Charged dust lifts more easily, which could help dust storms grow and support themselves. That creates something like a feedback loop. More dust, more charge, more storms. And there's a practical side too. These sparks won't hurt astronauts directly, but they could interfere with electronics or damage sensitive equipment. Knowing when and where they happen will help engineers design future missions and future spacesuits to handle Mars's electrically active environment. Now, let's move further away from the Sun. Here's something that might change how you picture the solar system. New simulations suggest that Uranus and Neptune might not be giant balls of ice after all. They could actually be much rockier on the inside, with thin icy layers around. Researchers at the University of Zurich ran new models and found that these ice giants don't have to be ice-dominated to match what we observe. In fact, many of their simulations work just as well if these planets contained a lot more rock than expected. Based on the data we have today, Uranus and Neptune could be rock-heavy or ice-heavy. There's just not enough information to choose between the two. That's why scientists keep calling for missions that would orbit these planets and study them up close. Voyager 2 flew past Uranus in 1986 and Neptune in 1989. It grabbed a few measurements and kept going. No spacecraft has ever stayed long enough to really figure out what's happening beneath the clouds. So scientists rely on computer models built from limited clues. The classic ice giant picture still works, but it's no longer the only explanation that fits the data. Now, another astonishing discovery involves Uranus's moon, Ariel. Even though it's small, scientists now think it could have once hidden a massive underground ocean that made up more than half of its entire volume. That ocean could have been around 105 miles thick, and it might have existed as recently as 1 billion years ago. Ariel is only about 720 miles wide, roughly a third the size of Earth's moon. Because of that, scientists used to assume it couldn't hold on to heat for very long. Newer research doesn't quite agree. When Voyager 2 flew past Uranus in 1986, it sent back images showing that Ariel's surface didn't look old and frozen. Instead, the moon looked relatively young and active, with cracks, ridges, and even signs of ice volcanoes. Some of those features look surprisingly similar to what we see on moons, like Europa, Enceladus, and Triton. And those are places we already know have oceans beneath the ice. Later on, scientists also found traces of ammonia and carbon-based compounds on Ariel's surface. Those chemicals usually don't last long, unless something keeps bringing them up from below, which often means liquid water underground. Researchers built models of what the inside of Ariel might look like. In their simulations, the moon had a brittle outer crust, a softer layer underneath, a deep ocean below that, and a solid core at the center. After that, they tested how Ariel's crust would react to tidal forces, the constant stretching and squeezing caused by Uranus and nearby moons. It turns out that if Ariel's crust was less than about 19 miles thick, it would crack under a serious amount of tidal stress. One source of that stress could be an interaction with another moon, Miranda, about 1 to 2 billion years ago. That interaction slightly stretched Ariel's orbit and put enough strain on the crust to break it. In any case, it's too early to claim that Ariel still has a huge ocean today. It's small, and it loses heat easily. If any liquid water remains, it's probably much thinner and not exactly a great place to look for life. Hey, what do you say we light a giant match on Jupiter, the largest room of explosive gas in our solar system? Jupiter has methane, a gas that's famous for its bright burning. Plus, there's metallic hydrogen, which, under the planet's extreme pressures, turns into a potent fuel. However, when we try to start a fire, nothing happens. There are no expected explosions. Now why is that? And can we fix that if we really want to blow up Jupiter? Jupiter is the titan of our solar system, the biggest planet we have nearby. It's 11 times wider than us. If Earth was a nickel, Jupiter would be a basketball. It's hanging out as the fifth one from the Sun, right after Mars. It's also more than 300 times heavier than our Earth, and twice as heavy as all the other planets combined. Because of this enormous mass, it acts as a moon magnet. Jupiter has 95 known moons. The most famous of them are the Galilean satellites, Io, Europa, Ganymede, and Callisto. They were discovered by Galileo Galilei in 1610. Jupiter also has some rings. Now, they're not as fancy as Saturn's though. Just faint rings made of dust, not ice. Because of that, they don't reflect light as brightly, and we can't see them with a naked eye. Jupiter also has the shortest day in our solar system, only about 10 hours. But it takes the planet about 12 Earth years to go around the Sun one time. But the most important thing about the planet is that, unlike Earth, it's not solid. Jupiter, as well as Saturn, are the so-called gas giants, planets made mostly of gases. Gas giants are mainly composed of hydrogen and helium, the same stuff that makes up stars. Jupiter and Saturn also have a dash of other heavier elements. This doesn't mean that the entire planet is just a ball of gas. The pressures inside are so harsh that molecules can't stay in that form. Their outer layers are made of compressed molecular hydrogen. As we dive deeper, it turns into a layer of liquid metallic hydrogen. Finally, there's a potential rocky core deep down. From the outside perspective, it looks like layers of clouds in their atmospheres. Jupiter also has these stripes and swirls that look like patterns. Now, in reality, they're chilly clouds made of ammonia and water, floating in a mix of hydrogen and helium. Its famous Great Red Spot is actually a massive storm that's been raging for hundreds of years. This storm itself is bigger than our whole Earth, and it's twice as fast as the Earth's fastest possible storms. So this is the problem we encounter when we try to light a fire on Jupiter. If you somehow manage to stand on Jupiter without any solid surface, while not caring about the titanic gravity and the crazy storms, fire needs oxygen to burn, and Jupiter's atmosphere doesn't have any. No oxygen, no flames. Well, let's assume that we have a magic match that can generate its own oxygen. That should work, right? Well, unfortunately, Jupiter is so massive that you would need an insane amount of oxygen to do that, perhaps way more than the entire solar system has. You might have heard that Jupiter protects us from dangerous asteroids. It's so gravitationally strong that it attracts all the objects that could have hit Earth otherwise. In general, Jupiter experiences from 30 to 100 collisions per year. Well, these meteorites falling on Jupiter didn't cause explosions either. Even the most powerful crash on Jupiter didn't. It happened with a comet called Shoemaker-Levy 9 in 1994. The comet broke into pieces in 92, some as big as half a mile. And then, in 94, it got a little too close to Jupiter. The impact was incredibly dramatic. Over 6 days, 21 fragments hurtled into Jupiter's atmosphere at great speeds. The planet's atmosphere heated up to 53,000 degrees Fahrenheit. Like a ripple effect from a tossed rock into a pond, the impacts created colossal plumes. They reached up to 1,900 miles above Jupiter's clouds. Dark clouds of impact debris scarred Jupiter's atmosphere for months, gradually fading away in the planet's winds. Now, this impact told us a lot of interesting things about Jupiter. For example, the dark impact clouds acted as wind tracers and revealed high-altitude winds in Jupiter's stratosphere. Changes in Jupiter's aurora helped us learn more about the planet's magnetosphere. And finally, it provided insights into Jupiter's chemistry. Comet Shoemaker-Levy 9 sparked NASA's interest in addressing the risks of impacts like that on Earth. This, in turn, helped us to learn more about comets and impacts in general. Saturn, the sixth planet from the Sun and the second largest in our solar system, is also a gas giant. Like Jupiter, it's not just a plain ball of gas. Even though it's mostly made of hydrogen and helium, at Saturn's center there's a dense core of metals like iron and nickel surrounded by rock. What's interesting is that it's much lighter than Jupiter. It's only 95 times heavier than Earth. Saturn has stripes in yellow, white, reddish, orange, pink, and green. Who came up with that color palette? Winds in the upper atmosphere can reach a staggering 1,090 miles per hour, even faster than on Jupiter and unimaginable compared to Earth. They look like colorful belts covering the planet, finishing with fascinating rings. Now, these rings are made up of bits and bobs from comets, asteroids, and shattered moons. There's even a Cassini division, a gap that separates some of these ring layers. Now, what about Uranus and Neptune? They're also giants, and for a while, scientists believed that they belong to the same family as Jupiter and Saturn. However, after a while, we discovered that they belong to a different category, ice giants. Again, they're not some giant ice cubes floating in space. Instead, they're mostly made up of heavier substances like water, ammonia, and methane, which could freeze into icy layers in their atmospheres. This is what sets Uranus and Neptune apart from gas giants, despite sharing some similar traits, like awful storms. Our solar system isn't the only one that has planets like that. There are also extrasolar gas giants, categorized by their atmospheric properties from ammonia clouds to entirely cloudless. For example, there are hot Jupiters, a separate category for, well, very hot Jupiter-like planets. They're gas giants that settle too close to their stars. For example, Kelt 9b and Kepler 7b are so close to their suns that 1 year on them lasts just 18 hours. Recently, we also discovered a little hot Jupiter. This planet, called HIP 67522b, is only a few million years old. Sounds like a lot, but it's nothing on a cosmic scale. Our own moon is about 4.5 billion years old. Now, this discovery challenges the norm. Most hot Jupiters out there are a way over 1 billion years old. We're still not sure how this one formed so quickly. What's even more interesting is how these hot Jupiters end up so close to their stars in the first place. Theories abound. Some say they formed right there, despite scorching conditions. Others believe they ventured in from outer space. For example, icy materials made together in a drifting rogue planet. And when it passed around the star, it got attracted by gravity and stayed in orbit. Maybe it happened early on, when the star was wrapped in a gas and dust cocoon. Or later. Scientists will need more research to say for sure. There are also weird oddballs. No, not me. Gas dwarfs. They're also called mini-Neptunes. They're smaller versions of gas giants that have rocky cores swaddled in thick hydrogen and helium blankets. They're called after Neptunes because, after being a bit smaller than this planet, they share a lot of similar traits. Their size ranges from about 2 to 4 Earths. Usually, it's a world with a hefty atmosphere, mainly filled with hydrogen and helium, and perhaps layers of ice, rock, and even liquid oceans beneath the surface. If a planet like that didn't have much gas in its wardrobe, we'd call it an ocean planet instead. We're not sure why they exist, and they defy some scientific norms. Like hot Jupiters, these planets require more exploration.
Billions of people are staring at the sky. Their eyes reflect a fascinating picture of how the planet's atmosphere is changing. The blue sky is becoming brighter and is taking on a dark blue hue. It looks like a drop of paint spilled in a glass of water. Birds have stopped flying, animals go crazy because they feel something is happening. Lightning flashes somewhere and the sky turns fiery orange. This is an approximate visual picture of what would happen if Jupiter's gas poured onto Earth. But let's find out what physical and chemical changes would happen in our world. First, we need to understand what Jupiter is and what it consists of. The largest planet in the solar system is a massive ball of gas. About 90% of this gas is hydrogen, and the remaining 10% is helium. Of course, there are other substances too, but their amount is insignificant compared to hydrogen. If you entered Jupiter's atmosphere and jumped down, you would keep flying straight towards the planet's core for a very long time. Scientists don't know exactly what the core of Jupiter is made of. There may be something solid and gigantic. Anyway, most of the time, you would be flying through blue layers of hydrogen, closer and closer to the planet's center. But why isn't this gas spreading in different directions? All thanks to Jupiter's gravity. The mass of the planet holds this gas together. Now, let's find out what hydrogen is. It's the simplest and most common chemical element consisting of one proton and one electron. Simply put, it's a universal gas that can store and delivers various energy. 90% of all atoms in the universe are made up of hydrogen. Hydrogen is a part of a lot of stuff, like water, many biological substances, atomic energy, and many more. Therefore, to get hydrogen in its pure form, people extract it from various substances using chemical actions. Hydrogen is inside our fluids, joints, bones, and muscles. It ensures the functioning of our bodies and contributes to the existence of life on the planet. Also, hydrogen slows down the process of aging. But if our planet received a huge dose of Jupiter's hydrogen, it wouldn't make us better, younger, and stronger. Hydrogen is only effective in combination with other substances. To benefit from it, you need complex chemical processes. But what about helium, which is also Jupiter's gas? It's lighter than air because of its low density. That's why helium-filled balloons rise up. People use this substance in medicine to treat respiratory diseases and to cool magnets and processes inside the MRI. Nothing terrible would happen if a massive amount of this gas got into our atmosphere. Our voices might become a little thinner. In any case, hydrogen would bring many more problems. Let's imagine that some cosmic force is moving Jupiter towards our planet. Then, for some reason, the core of Jupiter disappears. Hydrogen and helium begin to leak into outer space and fly to the nearest source of gravity, our Earth. The sky starts to turn a brighter blue. This happens because of the connection of water molecules with hydrogen molecules. Atmospheric pressure is increasing. Animals are going mad, and people are getting headaches. A few seconds later, the pressure disappears because hydrogen is easily ignited. Any spark can start a chain reaction. Hydrogen could burn the entirety of Earth's atmosphere, consisting of nitrogen, helium, oxygen, and other gases. All life on Earth would be erased in a matter of seconds. A tremendous amount of energy would be released. Earth's temperature would be only 2 or 3 times colder than the Sun's temperature and almost 4 times as hot as the surface of Venus. All the oceans would hiss and evaporate. Then the hot water vapor would fly away into space. Atmospheric pressure would disappear, but nobody would care about that. The planet would look like a big scorched desert. But what if people were ready for this? What if no one lit a match and people replaced all metals with plastic or wood? Unfortunately, it wouldn't help. There are millions of lightning strikes in the world every day. Any of them would ignite the atmosphere and destroy all living beings. People would have to figure out how to stop lightning strikes forever. But that would cause another problem. Lightning is necessary for our world to keep an electric balance on the planet. But anyway, this is a topic for another video. Luckily, pouring Jupiter's gases into our planet's atmosphere will never happen because Jupiter is too far away from us and its core will not disappear. But what if you flew to this planet and threw a match into its atmosphere? Nothing would happen. The match would go out the moment it leaves the spaceship. Fire burns only when it's in contact with air, and there is too little oxygen in Jupiter's atmosphere. Besides, it's contained in water molecules, and this is insufficient to create a flame. But what would happen if our planet became a gas giant like Jupiter? For this to happen, Earth must have a huge gravity. Jupiter holds all these gases because of its enormous weight. It's heavier than all the planets of the solar system combined, and 100-fold heavier than Earth. Imagine what would happen if our world's core started increasing in size and mass. If the planet got such a mass, all living things would disappear because of the enormous pressure. Earth would become the heaviest space body in the solar system, not counting the Sun. But life on the other planets wouldn't change much. Oh, but the Moon wouldn't be as lucky. The increased gravity of Earth would attract our natural satellite and tear it apart. The Moon would split into billions of parts and possibly form a belt around our planet. It would look like another Saturn. And what if Saturn used to be similar to our Earth? What if life once flourished on its surface? It could be a beautiful planet with oceans, forests, and mountains. But then something went wrong, and its core increased in mass. Its atmosphere began to grow and change the gravity of neighboring satellites. They collapsed and formed a huge belt around Saturn. And now, let's look at changes that would happen if Earth got Jupiter's gases slowly. Imagine our atmosphere filling with hydrogen gradually. In this case, new forms of life would appear on Earth's surface, like microbes and bacteria. Some of them could later develop into big forms of life. In the next thousands of years, the animal world on our planet would change beyond recognition. Perhaps we would see the appearance of new species of animals, microbes, and insects, and the disappearance of older ones. The consequences would be unpredictable. Fortunately, this won't happen. Right now, our planet has an ideal atmosphere. All life forms in this world are adapted perfectly to the amount of hydrogen that we have. By the way, there's a theory that Earth was originally the core of some gas giant. Billions of years ago, our planet could have been inside a gas giant close to the edge of the solar system. Perhaps this big guy was further away from Jupiter and Saturn. So this unknown planet traveled around the Sun and then it began to fall apart. Inside it, there was a collapse caused by the gravity of neighboring planets. The gas dissipated and our Earth came out of the cloud. Then it approached the Sun and took the orbit it follows now. And what if the same thing happens to Jupiter in a couple of billion years? For example, hundreds of giant asteroids could fly past it and destabilize the gas giant's atmosphere. Some of the asteroids would fall on the planet, provoking a strong release of energy. Jupiter would begin to fall apart and change its position in the solar system. And then, through the clouds of hydrogen, we'd see a solid core. And then it would get out of the gas cloud and approach our planet. Life would start forming there, and people would call this planet Earth 2.